So in this video, guys, I'm going to share with you all a very fundamental question that came in the May-June 2022 Cambridge International Examinations during their paper 1-3, and this is the ninth question for the same. The topic is from the forces and the dynamics, and the question is submitted by Aman. So thank you so much, Aman, for submitting this question. Now the question itself is not that difficult if your fundamentals are clear. Yet a lot of people struggled in this question. So let's see how we can do this. So a quick update for you guys before we move any further in this video. I'm documenting all the challenging questions in the Google Sheet whose video solutions I'm posting on my YouTube. So currently I'm just starting out, so that's why you're not seeing a lot of things over here. But as we go ahead in the upcoming few months, you will be seeing that you will be having a lot of questions to practice, which are only challenging or of a different kind that you might have not seen in the previous year's past papers. So if you want access to this kind of Google Sheets, both the links for the physics and the mathematics are present in the description of the video. You can check it out from there. Wishing you all the very best, guys. Let's move on to the video. So the question states that a ball is dropped onto a horizontal ground and bounces vertically upwards. When the ball is in the contact with the ground, the following forces act. First of all is the weight W of the ball, then the contact force P exerted on the ground by the ball, and then lastly the contact force N exerted on the ball by the ground. When the ball is in the contact with the ground, the ball is momentarily stationary. At this instant, which relationship is correct? So please pause the video over here if you haven't already given it an attempt and come back once you are ready. So welcome back, guys, if you did give it an attempt. The correct solution of this question is option D. If you did get this correct, congratulations, your fundamentals of the forces and the dynamics are rock solid. But now for the students who have attempted this question and marked A, B or C, let me tell you why they are incorrect and then finally explain you why D is the correct answer. I'll be also showing you the examiner report at the end of the video. But for now, let us understand what's really happening. So let me draw a quick diagram over here so that you can understand it in a much more better way. Here is the ground, and let's say at this particular height we are going to drop the ball, and after certain seconds it's going to hit the ground, and just before it hits the ground it's going to have some kind of a velocity v pointing downwards. Now because in the question they have mentioned that it's going to bounce vertically upwards, and they have not really mentioned about if there is any kind of energy lost in the system, and we can just assume that because it's going to bounce upwards, it's going to change its speed, or I should say the direction of the speed from the downwards to upwards. Only then it can go in the upward direction. So when it's just about to bounce, it's going to have the same value of the speed, but in the upward direction. So you can just call it as minus v because the direction has been changed. And let's say if I have to give any numerical example, just before it hits the ground, let's say that the velocity was 2. And then when it's about to move upwards, the value of the velocity will be negative 2. So in this process to convert the velocity from 2 to minus 2, so let's say from 2 it goes to 1, then 0, then minus 1 to minus 2. So in between, at a particular instant, we can say that it is momentarily stationary. But does it mean that the object, that is the ball, is in equilibrium? So the answer is no, because on that instant, the values of the velocity is changing drastically. It means that on that fraction of a second, there is a change in momentum. And we know that the net force acting on the ball will be equal to the rate of change of momentum. And because the rate of change of momentum is not equal to 0, there must exist a net force on the ball. And that is why it is not in the equilibrium. So now what about the direction of this net force? Because we know that the ball is about to move in the upward direction, the net force should be positive in the upward direction, which means that all the net forces in the upward direction should be greater than all the net forces in the downward direction. If this happens, only then we can say that the ball is about to accelerate in the upward direction. And based on this logic, let's see out of the given four options, which one makes the most sense. So just by observing the options A and B, I can see that there is an involvement of the force P, which is the force exerted on the ground. P is not the force that is exerted on the ball. So straight away we can reject the options A and B. What is the logic? See, our aim is to find out which are the forces acting on the ball that is causing the net upward acceleration. So because the force P has no impact on the ball, we can straight away reject the options A and B. So now we are left with options C and D. So option C would be correct if the ball was in equilibrium, where I'm saying that all the forces acting upon the ball are balanced. But over here, because we are having the net upward acceleration, upward force should be greater than the downward force. Upward force is N and the downward force is W. And therefore, we can say that the option D is the correct answer for this question. So I hope that now it's clear to everyone that why option D is the correct answer. Now let me show you the examiner report for the same. So here is the summary of all the comments made by the examiner for this question based on how students have attempted it in this examination. So there are majority of the two mistakes that they have highlighted. The first mistake is that they thought that the ball was in equilibrium because it was mentioned that the ball is momentarily stationary. Now I've already explained that why this is not true. And the second mistake was that a lot of students included the force P in their final answer, which is again not true because P is not the force that is acting on the ball, but it is on the ground and therefore should not be included in the final answer. So yes, if you be cautious about this kind of things in the final examination, even you can omit this kind of mistakes and be on those top students who can attempt this kind of questions with ease. So with these things being said, thank you once again, Aman, to share this kind of a question with me. I'll be uploading all these kind of challenging questions in this YouTube channel. So make sure that you are subscribing it and share it with all the students who might find it useful.